The Sun is the central star of a solar system, a massive and scorching sphere of hot plasma. It derives its energy from nuclear fusion reactions occurring deep within its core for many decades. Scientists have diligently observed and analyzed the Sun's behavior. One intriguing aspect of the Sun is its sunspot cycle, known as the solar cycle, which repeats approximately every 11 years. During this cycle, the Sun undergoes fluctuations in the number of sunspots, ranging from a minimum to a maximum. The current solar cycle, cycle 25, commenced in 2019. Solar scientists initially predicted that cycle 25 would feature a relatively low count of sunspots compared to previous cycles. However, recent developments have challenged these forecasts. Over the past few months, the Sun has exhibited increased activity, deviating from the expected pattern. This deviation has prompted researchers to reevaluate their predictions. In particular, the emergence of large sunspots, frequent solar flares, and other signs of heightened solar activity have left scientists both intrigued and cautious. The Solar and Heliospheric Observatory SOHO and the Solar Dynamics Observatory STO have been instrumental in monitoring these phenomena. The potential implications of this unexpected activity on Earth are of concern, as it could lead to disruptions in technology and communication systems. The significance of these observations lies in their indication that the Sun is rapidly progressing toward the peak phase of the solar cycle. Large sunspots, solar eruptions, and other phenomena are characteristic signs of this transition. While scientists hope that this solar maximum will not have severe repercussions for life on Earth, they remain vigilant in studying and understanding the Sun's behavior. The Sun's dynamic nature continues to be a subject of great scientific interest, offering opportunities for further exploration and discovery. As the solar cycle unfolds, scientists will continue to closely monitor the Sun's activity and refine their predictions, ensuring that we are better prepared for any potential impacts on our planet. Approximately every 11 years, the Sun transitions from a period of minimum sunspot activity to maximum activity, and then back again. However, the reason behind these solar cycles' duration has remained a mystery. Advances in solar observation technology have enabled scientists to gain a better understanding of these cycles. The first recorded observation of sunspots dates back to the year 1610, credited to Galileo Galilei. Yet, it wasn't until 1754 that solar scientists started meticulously tracking recording sunspot cycles. This route to be cycle 25, which began in 2019, was initially anticipated to reach its peak around 2025, with a relatively modest count of sunspots compared to previous cycles. This prediction was based on historical data and modeling. However, recent observations have challenged this forecast. In 2019, NASA, the International Space Environment Service, and the United States Space Weather Prediction Center (NOAA) suggested that the peak of cycle 25 might arrive sometime around 2025, with a maximum of approximately 115 sunspots. This projection was based on the information available at that time. Recent developments have spurred solar scientists to reevaluate their forecasts. In October 2023, NOAA officially issued a new prediction, stating that cycle 25's peak may occur earlier and be more intense than previously anticipated. The updated forecast suggests that the solar maximum could potentially happen between January and October 2024, approximately 1 year ahead of the initial estimate. Furthermore, the number of sunspots during the peak is expected to be higher, ranging from 137 to 173, a significant increase compared to the initial prediction of 115. These adjustments and predictions indicate that the Sun is exhibiting more activity than initially foreseen. It has raised concerns about potential impacts on Earth's technological infrastructure and communication systems. Solar flares and geomagnetic storms associated with increased sunspot activity can disrupt power grids, satellite communications, and navigation systems. Moreover, Solar scientists have also warned about the effects of this heightened solar activity on wildlife. Some animals, like whales and birds, use Earth's magnetic field for navigation, and disturbances caused by intense solar activity could disorient them. The sun's dynamic behavior continues to captivate scientists, and they are committed to closely monitoring its activity as cycle 25 progresses. Monthly updates based on real-time observations will provide a more accurate understanding of the solar maximum, as timing and intensity, helping us prepare for potential disruptions and impacts here on Earth. The sun remains a source of both wonder and scientific inquiry, but it's misused. As solar scientists closely monitor the sun-loving behavior during cycle 25, they are gaining valuable insights into the factors influencing these solar cycles and their potential consequences. One of the key drivers behind these solar cycles is the sun's magnetic field. The sun's magnetic activity follows an approximately 22-year cycle, known as the solar magnetic cycle or Hale cycle. This cycle is characterized by the reversal of the sun's magnetic poles every 11 years, leading to the completion of the full 22-year cycle. The sun's magnetic field plays a significant role in the formation of sunspots and solar flares. Sunspots are regions where the sun's magnetic field is particularly concentrated, resulting in craters and reduced radiation emission. These darker areas on the sun's surface are often associated with increased solar activity, including solar flares and terrestrial mass ejections. Solar flares are sudden bursts of energy and light, while winds are massive expulsions of solar material in magnetic fields into space. When directed towards Earth, these phenomena can interact with our planet's magnetic field, potentially causing geomagnetic storms on Earth, but also posing risks to satellites and our grids. The current uptick in solar activity, with the emergence of large sunspots and solar flares, suggests that the sun is rapidly approaching the peak of cycle 25. Solar scientists closely study these phenomena to understand their impact on space weather, which can have implications for our technological infrastructure, in addition to sunspots and solar flares. Another intriguing phenomenon associated with heightened solar activity is the appearance of solar prominences and filaments. These are enormous loops of solar material that can be seen erupting from the sun's surface. The interaction of these prominences and filaments with the sun's magnetic field can lead to stunning displays in the sun's outer atmosphere, such as solar prominences and filaments. While these solar phenomena are captivating to observe, they also serve as indicators of the sun's dynamic behavior. As cycle 25 approaches its peak, solar scientists will continue to monitor and analyze these events to refine their predictions and provide timely warnings about potential space weather impacts. Understanding solar cycles and their influence on space weather is crucial for safeguarding our technology-dependent society. By staying vigilant and well-prepared for the sun's fluctuations, we can mitigate potential disruptions and harness the power of scientific knowledge to adapt to the ever-changing behavior of our nearest star. As we journey through cycle 25, the sun's mysteries and revelations will continue to captivate scientists and space enthusiasts alike in the pursuit of understanding and predicting solar activity. Scientists employ various methods and technologies to monitor the sun. These observations are essential for tracking the progress of solar cycles and assessing their potential impacts on Earth. Solar telescopes and satellite. Advanced solar telescopes, both drone-based and space-based, have played a pivotal role in solar research. Instruments like the Solar and Heliosolar Observatory SOHO, the Solar Dynamics Observatory STO, and the Parker Solar Probe have provided us with unprecedented views of the sun's surface, atmosphere, and outer corona. These observations allow scientists to capture high-resolution images, study magnetic fields, and monitor solar phenomena in real time. Teleseismology. Teleseismology is a technique that involves studying solar oscillations or lumps to gain insights into the sun's internal structure and dynamics. By monitoring acoustic waves traveling through the sun, scientists can infer properties like temperature, density, and magnetic field strength beneath the solar surface. This information aids in understanding the processes that drive solar cycles. Predictive models to forecast solar activity. Scientists develop complex mathematical models that simulate the sun's behavior. These models consider factors such as magnetic flux emergence, the solar dynamo, and the evolution of sunspots and magnetic fields. By inputting observation data and running simulations, researchers can make predictions about the intensity and timing of solar cycles. Space weather monitoring. Space agencies and organizations around the world continuously monitor space weather conditions. This involves tracking solar flares, mist, and the solar wind. Early warning systems are in place to provide alerts when potentially hazardous solar activity is detected. These alerts help protect satellites, power grids, and communication systems on Earth. Citizen scientists also contribute to solar research by observing and decoding solar phenomena. Projects like the Solar Ring 3 years for it. Observatory. These collaborations expand the dataset available to scientists and enhance our understanding of the Sun. In recent years, advancements in technology and international collaborations have improved our ability to predict solar activity with greater accuracy. These predictions are essential for mitigating the potential impacts of space weather on modern society.